Okay, so question 1. The amount of milligrams of a medicinal drug in the body T hours after it is injected is given by this. Before the injection, the amount of the drug in the body was 0. Write down the initial dose of the drug. Now guys, I mean, before you do any question here, you could maybe, if you wanted to, draw the graph. So it's 23 times 0.85 to the power of x. You got to do x for a graph, remember. And then menu, zoom. Let's try zoom fit. That's not bad. We can zoom in after if we need it. So the initial dose of the drug, that's when t is equal to 0. Now guys, I know just from looking at this equation, when t is 0, like d of 0, that's going to be 23 times 0.85 to the power of 0. We know anything to the power of 0 is 1, so 23 times 1 is 23. It's going to be 23. But we can also find it here from doing menu, trace, graph trace, and you just move this along to 0, and it's 23. You can see 0, 23. You can also just literally type 0, press enter, and you get 0, 23. Anyway, the answer is 23. Part II, it says, write down the percentage of the drug that leaves the body each hour. Okay, now this isn't as straightforward, but because you're multiplying by 0.85, so when t is, I don't know, after 1 hour, you're multiplying 23 by 0.85 to the power of 1, which is just times 0.85. If you're multiplying by 0.85, you're actually decreasing it by 0.15 or 15%. So the percentage of the drug that leaves the body is 15%, only because that 0.85, 1 minus 0.85 is 0.15. That's where that 0.15 is coming. It's decreasing by 0.15 each hour, which is 15%. And then finally, part B, calculate the amount of the drug remaining in the body 10 hours after the injection. So look, this tells us the amount of the drug in the body after t hours. So after 10 hours, I just need to sub in 10. So that's d of 10, d of 10 is equal to 23 times 0.85 to the power of 10. You can, again, guys, use this. Look, if I just type in 10, it gives me 4.5281. 4.5281 or 4.53 milligrams mg. Okay, that's question 1.